Hey everyone, super happy to be here. I'm Leah, I'm a software engineer at Hiro, and I'm really excited to be able to talk about some developer tools today. So in this session, we're going to be diving into the process of writing and testing a Stack smart contract, and then we'll take a peek at how we would start to integrate our smart contract with some application code we are developing. We're going to be getting a little hands-on here with some live coding, but it will be totally beginner friendly. So even if you've never written a smart contract before, I hope you stick with me. Today, we're specifically going to be working on smart contracts on Stacks, a layer 2 chain on Bitcoin, which enables smart contracts anchored by Bitcoin. Okay, web development is hard. You've got to master a bunch of different technologies and adapt constantly to new tools and standards. The JavaScript ecosystem is quite honestly a bit of a Frankenstein monster. Tools and frameworks come and go, and it can feel like trying to build a sandcastle with the tide rolling in. And then take Web3 development. You have all the same challenges of web app development in general, and then add on the decentralization aspect. It's a totally different paradigm of thinking about data storage and software maintenance. There are new protocols and tools emerging constantly, and it's kind of the Wild West in terms of standards and best practices. How do you develop against the blockchain locally? What is the blockchain? What blockchain are we even talking about? You can't update your smart contract after you deploy it. Yes, it's immutable. You ship something to the blockchain and you can never, ever, ever change it. It's there forever. No rollbacks, no migrations, nothing. It's completely transparent and public. So anything you put on there, anyone can read it forever. It can be really overwhelming just to get started. Today, I hope to simplify the process for you and introduce you to some tools in your toolbox. At Hiro, we focus on developer tools for Stacks. Let's first take a look at kind of a high-level view of a decentralized application architecture. This is, of course, just a simplified concept. There are lots of different ways you could arrange these moving parts. There's a lot of other parts you could use, but take this concept. So a dApp built on Stacks might have some familiar parts for web devs, like a front end, a back end, a database. It'll also use a wallet browser extension to let users make secure and authenticated transactions on the Stacks blockchain. And your application, as well as your users through their wallets, will be interacting with the Stacks blockchain via calling functions in your smart contract, which is really the heart of your dApp. Smart contracts on the Stacks blockchain are written in a language called Clarity, and they store critical data and set the ground rules for your app's business logic. And they can also transact and hold Stacks tokens. Of course, every great app has to start with an idea. And the example we'll be getting started with today is going to be a decentralized crowdfunding application. So think Kickstarter, but decentralized and trustless. I think this is a really good use case to consider because it involves sending and receiving funds with a particular set of rules. You want your transactions to be secure and transparent. You want to have confidence in what's going to happen with your money, and you don't want to have to trust a third party to handle your money. Okay, so let's get started. This is the Hiro platform, which I kind of alluded to before, but it's a tool to help guide you through creating Stack smart contracts. So in here, you can keep your projects organized and access a hosted, full-featured development environment for you to build and test your smart contracts. So let's get started by creating a project. And you can choose from a few different templates we have, but I'll start with just a blank project. So here the platform is spinning up a hosted development environment, installing everything I need to develop smart contracts. I'll also mention in the Hiro platform, you can also access our hosted chain hooks service, which allows you to set up custom event streams for Bitcoin layers and trigger actions based on those events. And you can also generate and manage API keys to interact with Hiro APIs, such as the Stacks blockchain API, the Ordinals API, and the metadata API. I'm actually going to go ahead and generate one of these right now because it's going to come into play later on in our process. So I'm going to call our application fundraiser dApp, and I'll give it a short description. and I'll generate an API key for that. Okay, let's go back over into our project. So I've created this blank project. First thing I'm going to do is add a contract. Let's call it campaign funding. So we are then going to be given a blank template for our smart contract. And again, smart contracts in Stacks are written in a language called Clarity. And let's just go ahead and dive into it with some code. The first thing I'm going to do is I want to store my campaigns in some kind of data structure. So I'm going to use a map to do that. I'll just paste that in here. This is a data structure to store campaigns. And really quick, as we go through this, if you feel like the syntax is a little crazy, it is. If you don't have experience with like Lisp-like languages, there's a lot of parentheses. But once you get the hang of it, it's pretty simple because it's completely decidable and it's interpreted rather than compiled. So that means it's really self-evident. Like the code is 100% descriptive of the contract's behavior, which is a really nice feature to have when it comes to something like smart contracts. At the end of the talk, I'll send you to some resources to learn more about the syntax, but we'll just skim over some basics here. So this is a data structure to store our campaigns. It's a map where the key is an unsigned integer, which is going to be our ID for our campaigns. And then the value contains the campaign's owner, its title, the funding goal, the current funding amount. And then this end block height is going to store basically the duration of our campaign, which will be finished once the chain reaches that block height. Okay, so next, so we have our data structure, but how do we set data in it and pull data out? Let's start with a function to actually read a campaign out of our map. So this is going to be a read-only function. So we'll put it under this little comment. And these are just for help organizing. They're not, you don't have to follow them if you don't want to. You can just delete it and start from scratch. But just to keep your contract a little organized. So this is going to retrieve a campaign given an ID. And if the campaign is not found, it will return this error, which we actually have to define in a constant. So I'll go ahead and do that up here under my constants. And this is just a way to kind of set some ground rules for what errors the caller of your contract can expect to receive if something goes wrong. And then it will return our campaign if it's found. So finally, let's add a function to add a campaign into our map. This one's going to be a little bit more complicated. And this is not going to be a read-only function because we actually want to be storing data on chain. So this is going to be a public function. So I'll paste this in here. And then I'm also going to need to define a couple of constants as well, a new type of error. And then we are also going to be using a nonce to help generate our campaign IDs. So yeah, let's walk through this bit of code here. So again, notice that this function is a public function. Our other function's a read-only function. This is exactly what it sounds like. Read-only functions can read data from the chain, and public functions can change data on the chain. Public function calls always will create a transaction that needs to be paid for by someone with a gas fee, and then it needs to be mined and confirmed on chain. Whereas read-only functions respond instantly and they don't create a transaction. So this function sets a value in our campaigns map, and it uses these three function arguments to set the title, the goal, and the expiration block height by adding the current chain block height with the desired duration that the caller of this function wants. And it also initializes the total funding amount to 0. At the end, it increments the ID nonce so that we can use it for next time so that every campaign has a unique ID. And then it returns the ID of our newly created campaign. And if anything goes wrong, it just returns an error. Okay, so now we have a very simple but functional smart contract, which allows us to add campaigns and retrieve their data from the chain. So now let's think about what we want to do next. We would want to test our contract, make sure it's working the way we expect. If I hover over a function, I see this prompt to call that function. So I'll click on it and I'm prompted to start up a DevNet, which I'll go ahead and do. Let's talk about DevNet. So in order to call a function in a smart contract, the contract has to first be deployed on a blockchain environment. The contract code itself just defines the interface for the rules of interaction on the blockchain. But in order to actually make those interactions, to store data and make transactions, a blockchain needs to exist. And DevNet is your own personal sandbox blockchain. No one else can see it, and you don't have to worry about breaking it. You can tear it down, you can spin it up, you can deploy garbage code to it, you can deploy good code to it, whatever you want. You might also be familiar with the terms testnet and mainnet. And yeah, you can think of DevNet as your own local computer, whereas testnet is a public staging environment and mainnet is production, where the money is real. So in order to test our newly created contract, we're going to start up a DevNet, and then our contract that we're working on here will be deployed to our DevNet. And a bunch of test wallets that are pre-funded with Stacks tokens will be automatically generated for us to play around with. Because DevNet is like your own sandbox blockchain environment, it's a great place to quickly make changes and iterate on your smart contract in the early stages of development. You can also run a DevNet locally, but the Hiro platform can run a fully hosted DevNet for you to make it a little bit easier so you don't need to run Docker locally. This is especially useful if you're concerned about like memory usage on your machine. Okay, so I'm not sure why it's not started. Let's refresh and see if it's able to connect here. Sometimes our tools don't always work the way we want during a demo. Okay, awesome. So our DevNet is up and running. So let's go ahead and go back to calling a function. Okay, so you'll see this little message just for a couple blocks because the DevNet has to actually deploy my contract first. Okay, and there it went away. So now we're able to call our functions in our DevNet. So first we're gonna call get campaign. We know we don't actually have any campaigns yet, so I'll expect this to return an error, but I'm just gonna call it anyway. Okay, yep, so there it returns our not found error, which we defined as this unsigned integer of 2. So now let's call add campaign. And then again, because this is a public function, it's going to create a transaction on chain. So we need to call it as a specific wallet because someone's got to pay for the gas, right? So this call function as is a list of our automatically generated wallets for testing. So let's go ahead and just choose wallet 1. And now we can enter some values for our function arguments. Let's start a campaign to create the world's biggest pizza. How much is that going to cost in microstacks? I don't know. I'll just put a big number in there. And let's say that we want our campaign to run for 200 blocks. I'll click submit and I'll see that my transaction was submitted. I don't actually immediately see the result of my function call because my transaction needs to be mined and confirmed in a block first. So let's click to view our DevNet activity. Here, what we're seeing is a visual representation of the blocks in our DevNet. And because this is just my own little sandbox blockchain that I just started a couple minutes ago, there are only 6 blocks that have ever been mined in it. I can see that usually block 4, I can see that my campaign funding contract was actually deployed in my DevNet like we expected. And I can actually click on this to view the full Stacks Explorer view against my personal DevNet. So I can see this contract deploy was confirmed. I can scroll down and see that my source code here is what I expect it to be. And yeah, so I can see everything in here. I can poke around in here if I don't want to use the view in the Hiro platform. Oh, and there we can see my function call just went through. But let's go ahead and check it out here in the platform. So here's my add campaign transaction, and I can expand this to view the details of my function call here. It looks like it was successful. My campaign was added. It returned the ID of my newly created campaign, which is 1. So awesome. Let's go back to call get campaign again and just see if my function works as expected. I can put in the ID, call it, and then I will get back my campaign data. So we've now confirmed that setting and retrieving data is working as expected on chain with our smart contract. Okay, so what now? Let's take the next step. Obviously, if we were really building a real production ready app, we would probably want to add some more functionality to this, but just for the sake of time, let's take a view at the whole stack here. So let's take the next step and start to integrate this contract with some application code. So here I've created a really, really simple Next.js app just locally, and I'm currently running it here on port 3000. So I'll open it up here. It's like just the most boilerplate of Next.js apps you can imagine. So let's skim through the overall structure of our app code. It's very simple. There are really only 2 pages. One page here where you can view the campaign details. And there's a page to allow users to add a new campaign. And then there's this component connect wallet, which is a button to allow users to connect their wallets to the web front end. And then finally, there's this file in utils called Stacks API, which has this constant Stacks API root URL. And this stores the root URL of our Stacks blockchain instance that we're developing our app against. So to start with, I don't want to develop my app against Baynet. I want to develop my app against my DevNet. So how do I do that? I can actually go into the Hiro platform, go into my DevNet details, and open up this interaction console to grab the Stacks instance URL. And then I can just paste it right in here and save it. So if I want to develop my app against testnet, I would use the testnet API URL and so on. Okay, so next, let's take a look at the very simple functionality of the app. So on this page, campaign/1, you can view campaign info by ID. So we know that we have my pizza campaign that I just made on my DevNet right now. So on this page, what I'm seeing is the details for my pizza campaign. Obviously, this UX could use some work, but what we're doing here is my application is calling my read-only get campaign function on my DevNet to retrieve on-chain data and display it to the user. Let's talk about how this is actually working in the code. If we open up the campaign details page here, the magic is happening here in the call read-only function. This is an imported function from the Stacks.js transactions library, and we simply pass it some options. So the contract name, the function name, the arguments that we want to call the function with, and we get the response back. Then we wrap it in this helper function CV to JSON, which converts a clarity value to a more friendly format JSON, and that is also imported from a Stacks.js transactions library. And then we're able to get the campaign data from the chain and simply display it to the user in our view. So now let's talk about allowing users to submit transactions in your app. This is where the connect wallet flow comes into place. So if I go to campaign/new in my little test app, I see a connect wallet button, and I'm prompted to first connect a wallet to be able to add a campaign. The first thing to do here is I need to set up my wallet to be ready to use with my DevNet with one of my test wallets. So let's close out of this and go back to the platform with my DevNet interaction pane. I can go and view my wallets, and I can view details for any of these test wallets. And don't get too excited about being able to see these secret keys because this is all fake money. I'm going to be using the Leather wallet, and I'm going to be using my wallet 1. So I'm going to go ahead and click Connect Wallet again. I'm going to restore a wallet from an existing key and paste that in. And then this doesn't really matter because it's just for testing purposes. So once this is connected, yeah, I can see that my funds show $0. But what I'm expecting to see is, 100 million stacks. So what's going on there? I actually still have one more step to do, which is I need to add my custom network into the wallet, and then I'll be able to access my fake pre-funded wallet. So I can again go into my DevNet and copy the URL where it's living at. And then I can add a network in here and call it, fundraiser DevNet, add the network. And now I'm able to see my funds that I expect. Again, don't get too excited here. I also wish this was real, but it is not. Let's go back to my test app now. Okay, so now that I'm connected to my wallet, I can go through the whole flow here. I can choose the account that I want to connect to, and then the form to add a new campaign will display. So then I can fill out this form. Let's say I want to write a crypto poetry book, and I'm going to need at least 5,000 stacks to do that. And I want this campaign to run for 1,000 blocks. Okay, so when I click submit, I am prompted to approve this transaction with my connected wallet. Many of you have probably seen this view before. Once I approve it, I can see here that my transaction was submitted and I have got my transaction ID there. Obviously, this UX needs a bit of work, but it serves the purpose. So now we're waiting for our transaction to be mined so that our new campaign will be created. We know that we expect this campaign to have the ID of 2, but it doesn't exist yet because we're still waiting for it to be mined. So let's peek into our DevNet in the platform here. We can see the transaction hasn't yet been confirmed in the latest block. And we know from looking at our app that we don't see anything here. This is another really interesting limitation of Web3 development, and there are lots of different strategies to handle this to create a smooth UX. I'll just mention this briefly, but I won't have time to dive into it too deep. But one strategy that I've personally found really useful is using chain hooks to have your app notified when new blocks are confirmed so you can keep your application updated appropriately and just have like full control over the user experience. Perfect timing. This transaction was submitted here in block 15, and my second campaign, well, let's see if it worked. Yep, my second campaign was created. So if we go back into our app and we refresh this page, we now see the campaign details. Okay, so now let's take a look at the code that makes this happen. Let's open up the new page. You'll see it renders this connect wallet button. Let's go into there. This button, the magic again here is in Stacks.js. So it imports the show connect function from Stacks.js connect library. And this is where it's being called. You can pass it some details about your app, and then you get access to a couple of callbacks that let you handle the flow of what should happen after the user connects their wallet. And then through the user session here, which is also imported from Stacks.js, I can access the connected user Stacks address, but it's completely secure. So my application obviously never has any access to the user's sensitive data. In this component, I've wrapped the data about the connected wallet in a React context to allow the state to be accessible globally in my app code. So let's go back to the new page. This page renders that form you saw where the user can type in details about their campaign. You'll see a bunch of labels and inputs. And then let's take a look at how the transaction to create the campaign is being sent to the user for approval. Again, Stacks.js, we just keep going back there. So if you look at open contract call, this function is imported from the connect library. And when I call open contract call, I pass it some configuration about the contract call that I want to make. The contract, the function arguments, and of course, the network so that it knows that I want to call this function in my DevNet. And then I pass callbacks to handle what should happen in my app once the transaction is submitted. Here in this onFinish callback, I can actually have access to the transaction ID and then do whatever I want with it. In this little test app, I'm just plopping it down at the bottom of the screen, but you can imagine some very useful things you could do with it. Okay, So, yeah, you've now seen a little slice across the stack of the process of building a decentralized app on Stacks. We wrote a functional smart contract and we integrated some front-end application code with our DevNet to make calls to that smart contract to fetch data and submit transactions. So what would our next steps be if we wanted this app to actually be real and production ready? So first, we'd need to finish out the functionality of the contract. There's a lot of missing functionality if we wanted to build a real crowdfunding app. We'd want to create functions to let users make contributions to campaigns, transfer Stacks tokens from the contributors into the smart contract, add some logic to release the funds to the campaign owners when a campaign is finished. And again, that's an area where chain hooks might be really useful as well, things like that. Next, we might consider adding some unit tests for our smart contract to enhance maintainability and give us extra confidence. There's another Hiro tool called the ClearNet SDK, which makes it really easy to write and run unit tests for smart contracts. There's actually a YouTube video, I think I am the one talking in it, about ClearNet SDK and building unit tests for your smart contracts in the Hiro platform as well. So if you're interested in that, you can look that up. And then, yeah, if you're used to writing unit tests in like JavaScript, you'll be very comfortable writing and running these unit tests for your smart contracts with the ClearNet SDK. And then, of course, we'd want to build a whole front end and make it look nice. I obviously need some help from a UX designer to do that. And then there would probably be more application data that we'd want to store besides just what is stored on the blockchain. Remember that like storing data on the blockchain is expensive and again, it lasts forever. So there are other strategies to store application data. You can even do it in a fairly decentralized way despite it not existing on the blockchain. So there's different strategies for that. So in this case, it might be something like we would want to allow campaign creators to upload an image or add a project website to their campaign. That stuff isn't necessarily critical to live on the blockchain, but it's important for our app experience. So we might consider adding a database to store things like that. And then once our application is fully working, we're done developing it, or at least we feel pretty confident, we would then just deploy our smart contracts to the Stacks testnet as a staging environment. And in testnet, you can use a faucet to get fake Stacks tokens to test your app with. And then mainnet is the real deal, where the money is real. So yeah, and the Hiro platform can help you do all of that with the deploying your contracts with a feature called deployment plans. All right, so that's what I've got for you today. You can find some references and links at hiro.so/cheat sheet. And that includes the smart contract code that we worked on today, along with some more full-featured application code for our app idea. Again, my name is Leah, and we always want to hear about your experiences with our tools, so please reach out on the Stacks Discord to chat. Myself, I and my team members hang out on the Hiro platform channel in the Stacks Discord all the time. So if you ever have any questions or suggestions, please come and find us there. So yeah, thank you so much and happy building.